I am Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science, Jesus and Mary College, University of Delhi. So friends, this is a series which is ongoing and we are talking about different aspects of data mining in this series. So in the previous lecture, in the preceding lecture, we had spoken about cluster analysis and we were trying to figure out what exactly is cluster analysis and how cluster analysis varies or how it differs from other techniques which are used in data analysis, right. So we had seen that cluster analysis is sometimes also known as unsupervised classification. Unsupervised classification, why? Because in the classification technique we had seen that we compare the data with the model, with any data object that we want to assign a class to, we will compare it with a model. We develop a mathematical model, an algorithm, and using the properties of that particular object, we will assign a label to the object, right. So this is known as supervised classification because we have a model to use and we have used some training data to train the model so that it can predict the class of an incumbent object. But for clustering, what we were doing in clustering, we say that it is unsupervised classification. Why? Because here there is no model that we are going to use and we are simply going to divide the data into different groups or clusters so that the objects which are very similar to each other, they will become a part of one cluster and those which are unrelated will go in another cluster. So the objects within the same cluster will be very closely related to each other, whereas the objects in two different clusters will be very different from each other. There will be a lot of distance from each other, right. Now we also come across different other techniques of data analysis like segmentation and partitioning. So it's also important to understand that how clustering it differs from segmentation and partitioning, because sometimes these terms are used synonymously with clustering, but as a data analyst it should be very clear in the mind that what is the meaning of clustering, what is the meaning of classification, what is the meaning of segmentation and what is partitioning, because technically these techniques are different, computationally these techniques are different, right. So for example, when we use the term partitioning, right, so partitioning is often used in connection with techniques that divide graphs into subgraphs, okay, and that are not strongly connected to clustering. So in clustering we are dividing objects into different groups, but in partitioning we are actually cutting the graph and making subgraphs out of it, right. So segmentation will refer to the division of data into groups using simple techniques, right. Like for example, if you are dividing an image based on the pixel intensity or on the color, okay, or people can be divided into groups based on their income. So what is that? That is simple segmentation, but clustering is not done in this format, right. So therefore clustering is completely different from segmentation and partitioning, right. So now we know that there is a collection of clusters which we are referring to, and this entire collection of clusters is commonly referred to as a clustering. So together the whole collection, all the group of clusters is known as a clustering, right. Now we can have various types of clusterings, like we can have hierarchical or we say nested versus partitional, that is unnested clustering. We can have exclusive clustering, we can have overlapping clustering, and we can have fuzzy clustering, and then we can also have complete versus partial clustering, right. So these are different ways in which the groups are created, the groups are organized or the clusters are organized, right. So first let us look at hierarchical versus partitional clustering. Okay, so in this diagram we can see that we have created 4 different types of clusters, actually 5 different types of clusters from the parent dots, right. So here we are looking at dots as different objects, and these objects are divided into different clusters, right. So this type of clustering, that is hierarchical clustering, is very commonly discussed, and what we are looking at is the distinction among the different types of clustering, right. So here it is nested or it can be unnested, right. So in more traditional terminology we say this is hierarchical or this is partitional, right. So in hierarchical, what we mean is that the clustering is completely in the form of a tree. In partitional, it is simply a division on the set of data objects into non-overlapping subsets, right, such that each data object will belong to exactly one subset, right. So actually if you look at it, if you divide it in the form of a tree type of structure, if your subclusters together join to form your cluster, it is a hierarchical, and if you cut a part of that tree, it is called partitional clustering, right. So if we permit clusters to have subclusters, then we obtain a hierarchical clustering, right. Why? Because it is a set of nested clusters that are organized as a tree. Nested clusters means that there are within one cluster there are multiple clusters. So what we are doing, we have one big cluster. Now from that cluster we are dividing and creating further subclusters, okay. So if you will combine the subclusters, you will get the parent cluster, okay. So we are organizing these clusters in the form of a tree. Each node in the tree except for the leaf node, okay. So node here means the cluster, right, and the cluster is then divided into the subclusters, right. So this leaf node means the end nodes, okay, which are not further divided. So each cluster is actually a union of its children or subclusters, and the root of the tree, that is the topmost cluster, will contain all the objects. So that will be the you can say that will be the superset of all the objects which are lying in that entire clustering, right. So the leaf of the tree, the ultimate nodes or the leaf nodes of the tree, they are singleton clusters of individual data object. That is, now when you reach the leaf, it means that you cannot further create subclusters out of that particular node, right. So hierarchical clustering is actually viewed as a sequence of partitional clusterings, and partitional clustering can be obtained, as I just said, it can be obtained by taking any member of that sequence. That is, if you cut the hierarchical tree at a particular level, what you get a partitional clustering, okay. So if we look at this diagram, here it is very clear that the A diagram, the picture A represents the original point. So we are looking at simple dots here, and out of these dots we are going to create clusters. So first in the B part we can see that 2 clusters have been created. Now further each of those clusters has been subdivided and 4 subclusters have been created, and then from those 4 subclusters further 6 subclusters have been created. So you understand that in the figure D, actually the 6 clusters, they belong to the 4 clusters of C, and the 4 clusters of C actually belong to the 2 clusters of B, and the 2 clusters of B actually are the part of the original points which we are seeing, right. So what is this? This is nothing but a hierarchical organization of the structuring. Then the next type of clustering that we see is exclusive versus overlapping versus fuzzy. Now exclusive, the word exclusive itself means that each object will belong to a single cluster. There will be no overlap, that is, there cannot be any object which can belong to more than one cluster, okay. So here what we are saying, that there are many situations in which a point could reasonably be placed in more than one cluster, okay, and these type of clustering are known as non-exclusive clustering, right, or sometimes we also call it as overlapping clustering, right. So what we are trying to say, in overlapping clustering is that the object can belong to more than one group at the same time. Okay, but if you talk about an exclusive clustering, then in that case it means that the object will only belong to one single group. Like for example, if we take an if we look at a person at a university, right? Now a person at a university can be enrolled as a student as well as the employee of the university. So here the person is actually belonging to both the clusters, the cluster of student, the cluster of employee. So in practical life scenarios also there will be multiple situations where we will see that an object, a data object can belong to multiple clusters, that is overlapping cluster. So this non-exclusive clustering is often used when you also have an object between two or more clusters. Okay. So what we are saying is that instead of making an arbitrary assignment of the object to a single cluster just for the sake of making it an exclusive clustering, it is always better to place the object in all the equally good clusters. So if a particular object is belonging equally to multiple clusters, then it should be placed in all those clusters instead of just placing it in one cluster. Then the next type of clustering is very interesting clustering, that is fuzzy clustering, right. So in mathematics also the fuzzy algorithm has been used, and the same algorithm is being used here also. So what we are doing is that we are giving every object is belonging to every cluster with a membership weight, okay, and the membership weight is between 0, that is 0 means that the object does not belong to the cluster, and 1 which means it absolutely belongs to the cluster, right. So each object is a part of every cluster, but a weight is given to it between 0 and 1. Okay. So 0 means the object doesn't belong to the cluster, and 1 means that it belongs fully to the cluster, right. So what we are saying is that we are actually treating the clusters as fuzzy sets, right. So if in mathematics the fuzzy set is a set in which every object belongs to every set, okay, with a weight that is again the same thing, that is between 0 and 1. So here also we are using the same logic, that we we put additional constraint sometime, that the sum of the weights for each object must be equal to 1. That is, if an object is belonging to 3 clusters, okay, so the sum of weights in all the 3 clusters should not exceed 1. Why? Because 1 is the maximum possible probability or the maximum belongingness that an object can have to a particular cluster, right. So probabilistic clustering techniques like fuzzy will compute the probability with which each point belongs to each cluster, and we also know that probabilities also sum up to 1 only, right, because the membership weights or probabilities for any object sum to 1. So therefore a fuzzy or probabilistic clustering does not address for true multi-class situation. Multi-class situation is what? Where we know that a person is both a student and a teacher, okay, or an employee, okay. So in this case, in the student also the probability of the person belonging to the student cluster is 1, and the probability that the person should belong to the employee category should also be 1. So here this is a multi-class situation where an object equally belongs to both the classes. So in those situations this fuzzy clustering and probabilistic clustering may not work, okay, but otherwise in situations where this decision has to be made that in which cluster the object must be placed, okay, there we can use this logic, because we can assign the object to the cluster where it has got the maximum weight or where it has got the maximum probability, okay. So instead of arbitrarily assigning the object to any one cluster, we can easily choose, because now we have got this weight or we have got an objective basis of assigning the object to a particular cluster, Okay, so this is converted into exclusive clustering by assigning each object to the cluster, as I just said, wherever the weight or the probability is highest. Okay. Now another type of clustering is complete versus partial. Okay. Now the name itself suggests that complete clustering means that every object will be assigned to a cluster. Okay, whereas partial clustering means that it is not necessary that all objects will be assigned to one cluster or not. Okay, so partial clustering basically is that some objects may not belong to any of the well defined groups. Like for example, these there are objects in the data set which are which represent noise, or which represent outliers, or they are uninteresting background. So this kind of data object need not be assigned to any group. Okay. So this clustering is known as partial clustering. An example of partial clustering would be, like for instance, we are looking at newspaper stories, okay, on global warming. Now we know that there are two types of stories in the newspapers, one which will focus on a particular theme, and then others which are more generic or one of a kind types. So when we want, if we want all the stories which are important for that particular area, so we will only want to look for documents that are tightly related to a common theme. So we will, what we will look at is, we will only look at the complete clustering. Okay, and we will leave the partial ones. Partial ones will be those which are having more generic type of information. So those we will not put in our cluster, and the ones which are more tightly related will be put into the cluster, right. So complete clustering of objects is also desired in certain situations, like for example, when we are browsing the documents, right. So it has to be made sure that all the documents have to be browsed, right. So clustering will be used to organize the document for browsing, right. So there are situations where we require complete clustering, there are other situations where we will only require partial clustering. Okay. So this was a discussion on the different types of clustering techniques which can be used, how we can cluster, create the cluster, whether it is exclusive or it is overlapping or it is complete or it is partial. Different types of clustering techniques can be used for creating the cluster. Now when we create the cluster also, there are different types of clusters which are created. Okay. Now basic aim of the cluster, as we have already seen, it could be either usefulness or it could be adding more understanding. Okay. So clustering aims to find useful groups of objects, okay, and usefulness is defined by the goals of the data analysis. So how do we know whether our cluster is a useful cluster? Because we must understand why exactly the clustering analysis is being done. Okay. So there are different types of clusters which can be created. Okay. So first is the well separated clusters, then we can have the prototype based or center clusters, we can have graph based clusters or contiguity clusters as they are also called, then we also have density based clusters, and we have situational clusters or conceptual clusters. So we will look at each type of these clusters and see what are the different properties of each type of cluster that we are creating, and what can be the probable situations in which a particular type of cluster will be chosen or will be created, right. So when we say well separated cluster, so in this diagram it is shown that the set of objects in which the object is closer or similar to every other object in the cluster than to any other object in which is not in the cluster. So here what we are looking at is, we are looking at two dimensional dots, right, and these circles, they are representing the two different clusters which we are creating, right. So the objects within one circle, they are very closely related to each other, and they are not related to the objects in the other circle or in the other cluster. So, these what we can say is that this is a well separated cluster which has got no overlap. Okay. So, a threshold is also used sometimes to specify that all the objects in a cluster must be sufficiently close, that is, they must be sufficiently similar to one another, and all the objects which are in two different clusters, they should be very different from each other, right. So, idealistic definition of a cluster that we have already discussed is that the data contains natural clusters that are quite far from each other. That is, the distance between any two points in different groups is larger than the distance between any two points within the group. This is what we are discussing again and again, that the intergroup distance has to be less and the intragroup distance has to be less and intergroup distance has to be more. Okay. So, then only we will say that the clusters are well separated clusters. Okay. And these need not be globular also, they can have any particular shape. So, we can see in this diagram also that these two clusters, they are well separated because the distance between the two clusters is quite high than the distance between the objects within the same cluster. Then the second type of cluster that we see is the prototype based cluster. So, we already discussed the concept of prototype. We know that in a cluster we have a set of objects and each object is closer or it is more similar to the prototype that defines the cluster than to the prototype of any other cluster, right. So, what is a prototype? A prototype is a representative of the characteristics of the particular cluster, right. So, every object will resemble the prototype very closely and it will not resemble the prototype of another group, right. So, for data which has got continuous attributes, the prototype of a cluster is often the centroid. How do you find out the prototype? That is the average or mean of all points in the cluster. So, that is your prototype. If your data is not continuous attribute, it does not have continuous attribute, okay. So, in that case centroid is not going to be meaningful. So, when we are looking at data which has got say categorical attribute, in that case what you do, we take the medioid value to be the prototype. What is medioid value? The most representative point of a cluster, that point which is having the maximum representation, right. So, here what we do is that for many types of data, the prototype is regarded as the most central point, and in such instances we commonly refer to the prototype based clusters as center based clusters. So, therefore, we are using the term prototype based or center based clusters. So, such clusters, they have to be globular. Why? Because we are actually centering our distribution, we are actually centering our the properties of the cluster or of the prototype on the particular central tendency, whether it is the centroid or it is the medioid, right. So, friends, we have discussed two types of clusters in this discussion, that is the prototype based clusters and the well separated clusters. There are further different types of clusters which can also be discussed. So, we may continue our discussion on the types of clusters in the preceding lectures. Till then, please keep watching CEC. Thank you.